Good afternoon. I am Ciro Allarà, a second-year PhD student at University of Bolzano. And today I present you this work related on the fabrication of a temperature sensor via direct laser writing on a paper substrate coated by copper nanoparticles ink. And this work was done in collaboration with the colleagues at Sensing and Technology Lab at the University of Bolzano and in collaboration with the group of Professor Niels Benson at the Institute of Technologies for Nanostructures in Germany. As we explored the temperature sensors, we find out that there are a lot of materials that are used as substrate, and these materials associated with different fabrication techniques gives some advantages, like, for example, high precision, stability, high thermal resistance, and high thermal stability. But also they share a disadvantage, that is the fragility of the substrate and the rigidity. This disadvantage can be overcome by using a flexible substrate, like paper. But why paper as substrate? Because paper is an abundant material, it is low cost and biodegradable and biocompatible, and these three characteristics makes it very attractive for eco-friendly and sustainable applications. But also it is flexible, so it can be applied to not flat surfaces, low weight, and it is considered by fiber, so it allows the fact that the ink that is considered by the conductive metal is better absorbed. But it has also some limitation, like the fact that since it is an organic material, it is easily degradable, it is very sensitive to the temperature, and also the fact that it is considered by fibers could lead some imperfections during the fabrication. But even if it has this limitation, it is widely used in flexible electronics in wide range, like, for example, wearable sensors for health parameters monitoring, flexible devices, and precision agriculture. In our work to this substrate, paper-based substrate, we associated the direct laser writing technique. Why? Because this technique is localized and selective, so this means that only the material that is heated by the laser beam is modified, and also it does not need any mask or any intermediate step to be applied, and also it is customizable, so by tuning the laser parameter, it is possible to customize it for different application. Also, it is a very rapid process, and this is very helpful if you are using a flexible substrate like paper that are very sensitive to temperature, because paper undergoes to degradation or deformation under high temperature, and since it is very rapid, it is suitable for this kind of substrate. And also it is environmental friendly because it reduces waste. At the end of this brief introduction, what I want to tell you is that the traditional fabrication techniques are still fine, but they are high cost. They are incompatible with the flexible substrate, and also they are complex and multi-step. So what we are presenting here is these novel techniques with dynamic laser writing and copper nanoparticle ink that is low cost, since the copper nanoparticle ink is cheaper than the silver ink that is most commonly used in this kind of application, and it has also a good conductivity. It is simple and direct, and also it reduces waste, as we said. So the aim of our work is to develop and characterize this sensor that is flexible and fully printed, and that is done with the environmental friendly and low cost material in order to monitor the temperature in a wide range of contexts. Regarding the fabrication that was done at the Institute for Technology of Nanotechnologies for Nanostructure, follow this step. First of all, the copper ink was automatically printed on a paper substrate. Then it was let dry overnight at room temperature, let's say at 22 Celsius degrees. And then the dynamic laser writing was applied in order to generate the interdigitated electrodes. And the optimization of this parameter was done in another work also with other colleagues of the Sensing and Technology Lab. And at the end, a P.PSS layer was manually printed on a region of interest of the sensor. Why P.PSS? Because P.PSS has a high electrical properties, and also because it is very sensitive to temperature, so it makes this very attractive for this kind of applications. Then we characterized our sensor in lab with a custom-made setup, in which there is this chamber, and inside there are Petti, and on the top of it are put our sensors. These chambers has one inlet that is split in two. One that let the dry air enter inside the chamber, and that is connected directly to a compressed air bottle, and the other one that provide wet air, and that is connected to a compressed air bottle, but that is connected as well to a bubbler in order to control the humidity condition in the chamber. This compressed air bottle is controlled by two mass flow controller that has connected to a PC that is able to control the mass flow controller, but also the measurements units that is constituted by a digital multimeter and a source measurements unit that are able to control the temperature of the Petti and to read the resistance of the sensor. We characterize our sensor in a temperature range that goes from 25 Celsius degrees to 50 Celsius degrees with the 5 Celsius degrees step, and at three different humidity levels, 30, 50, and 80%. First of all, we measured the resistance of the sensor, and as you can see, it has a inverse behavior with respect to the temperature. So by increasing the temperature, the resistance decreases, while by decreasing the temperature, the resistance increases. And this is also observable in the in the calibration curve, in which you can see that the response is decreasing by increasing the temperature, and also that the standard deviation is lower at lower temperature and higher at higher temperature. This means that the measurements are quite stable at lower temperature rather than higher. Then we measure also the repeatability of the sensor by making cooling and heating cycles at 25 Celsius degrees and 50 Celsius degrees respectively. And as you can see, there is a high repeatability for the response. And at the end, we also measure the resistance at different value of humidity. And here it is possible to observe that there is a humidity independent trends because the behavior is the same at different values of humidity, but there is a slightly humidity dependent values because by increasing the humidity, the resistance start to decrease. So, in conclusion, what I show you is this sensor that was done by a very simple fabrication technique and that gives accurate results, and that is also eco-friendly and cost-effective. What we want to do in future is to try to do measurements in outdoor experiments, so in different environmental conditions, in order to understand if the measurements temperature are affected by environmental condition, and also to check the durability of the sensor under, for example, the presence of rain or wind. And also we are thinking of materials that are able to, with which we can encapsulate the sensor to have humidity independent measurements of temperature. So thank you. This is a picture of our group at Bolzano Sensing and Technology Lab, and thank you for your time, and if there are questions.